One of the 5 factors of soil formation is parent material. Here at this site, we're going to begin focusing on the parent material as we think about how the soil has formed.
Right here we see 2 types of parent material. The 1 meter thick, somewhat looser material is essentially glacial debris, which was distributed over the site by water action, and later on we will find out that the sea invaded this area, so it was essentially wave action too in sea waters. The other parent material which we see here right at the bottom of the soil pit is somewhat compacted and indurated material, and it was deposited by the sea which was invading this area after the ice retreated. The last glaciation, which we call a Fraser glaciation, ended roughly 10,000 years ago, and the huge quantity of ice depressed the earth crust, and this depression is estimated or measured to be 150 meters, and so certainly it was below the sea level, and a sea invaded this area and deposited this material, which obviously wasn't this hard and compacted as it is now, but soil formation caused this compaction, and silica type of materials cemented, especially the surface layer of this. We refer to this as glacial-marine deposit, and this is rather impermeable to water, and this essentially represents the base of root penetration of the plants, because no self-respecting plant would want to root into that hard material.
Andy, can you tell me what this brown material is that appears to be sitting on top of the parent material at the bottom of the pit?
The soils people refer to this as a root mat, which forms on the surface of this indurated, poorly permeable material. And actually, now another soil forming factor comes into play here: climate. We have very heavy rainfall here, especially during the winter months, approximately 60 inches a year total precipitation, which in metric calculations would come to about 1,500 millimeters. And of course there's a little bit of a slope here, and this rain, heavy rain, goes through all the available permeable soil and start flowing on the surface of the poorly permeable layer in a form which we call seepage. And of course trees want moisture, and they put their fine roots down there to take the moisture, and throughout the centuries large quantities of fine tree roots just trace along the surface of this impermeable material. They don't root into the material because it's very compact, so they just feed in there, and eventually this mat forms there, which contains essentially here partially decomposed root material. And this might even have roots of the virgin forest which was existing here. And of course we know that this was mainly composed of Douglas fir and western red cedar and western hemlock. We don't see those trees here anymore because of course the land was cleared earlier by loggers in the end of the 19th century, and then later on as the university endowment land was developing, of course they may have thought of housing in here, and they cleared all the remnants of the virgin forest, and the area was invaded by plants which we call pioneer species, and those are the ones which we see here. And the major component of this is red alder, and then of course we can see bitter cherry and vine maple, and a species which grows the tallest here and the biggest is broadleaf maple.
When I was digging the pit, I found this rock-like structure. Can you tell me what happened here?
Yes, Rachel, when you look at this, we find out that really this is not a rock, because I can pry it apart with my knife, and this is well known in this area, and this essentially reflects our soil formation. The heavy rainfall leaches all the minerals from the surface soils, and the weathering is so intense that the clay particles are broken down to their oxides, and the most resistant oxides, iron and aluminum oxides, essentially cement the soil particles, and this is the result of that cementation. And if we look a little closer, we find little nodules in here, and even these little nodules I can cut with my knife, and these are called in soil terminology as concretions. So, and this refers to the major soil in this area, which the Canadian soil scientists identify as podzolic soils. And the reddish particles indicate, of course, essentially rusted iron oxide, and this gives the name of the soil, which would be a ferric. The chemical term of iron is ferrous, so ferric type of soil. So it's a ferrous podzol.
Another fun thing I found while I was digging this pit were randomly placed rocks, such as that.
Well, Rachel, this has a long history. This is not really a country rock here, because it was brought here in last glaciation, say 15,000 years ago, from the North Shore Mountains. And that's why we refer to these as glacial erratic, because it's part of the coast mountains, which is a large granitic batholith. When this started to crystallize, it formed rather large visible crystals by the naked eye, and we could see that if I use a rock hammer and open up a clear surface, and we could see the speckled crystals are mostly quartz, and the darker crystals are plagioclase, and so on.
Let's discuss the characteristics of each of the horizons here.
Well, in soils we usually recognize different colored bands, and these are the ones which we call horizons. And here we can see a few. It's good to clear off a face completely to see the true colors. So I will try to do that now. Going all the way through, And of course, as I poke through it with my knife, I feel different densities, which also helpful to a soil scientist to recognize these features. And of course, see the true colors. And then once this is complete, then of course we can put a measuring tape beside it. And now, starting from the top layer, we recognize an organic layer here, which is made up of moss and twigs. And interestingly, in this area, the organic layer is not built up into a greater thickness, which is usual in our coniferous forests. But here, this organic layer quickly decomposes and turns into a surface organically enriched mineral soil with very nice crumbly structure, almost approximating agricultural and garden soil conditions. And this is characteristic of the top 5 centimeters, going from zero level here. And this we would identify as an organically enriched A horizon, so we notify it as AH. But I can see two differences in here, so I would call this AH1, the first 5 centimeter from 0 to 5, and then deeper down the soil seem to be losing the crumbly character and shows these little blocky structural forms, but still quite dark, so organically enriched. So say from 5 centimeter down to 20 centimeters, that would be another A horizon, and we would notify it as AH2 because we already selected an AH1. So the surface horizon, 20 centimeter thickness, which is very unusual in this area, is the AH1 and AH2. The soil people would refer to this dark colored A horizon as sambric horizon. Somber means dark, and we don't have a pH meter here, but if we would take a sample of it and check it for pH, and perhaps you can do this in a lab when you collect samples, you will find out that it is, from agricultural point of view, is still quite acidic. I suggested 5.5 to 6 pH. Agricultural people like a neutral pH level 7.
I noticed that in the A horizon there are a lot of roots. What about the B horizon? It doesn't look like there's that many roots. Can we talk about what else we know about the B horizon?
Well, we already mentioned that the A horizon is organically enriched, and the organic matter has very good moisture holding capacity, and of course the fine roots utilize this and aggregate in there. Now the B horizon of course lacks organic matter, so roots don't have as much feeding properties in there. They may go down there for moisture, and also the B horizon, which starts below 20 centimeter, perhaps there is a little transitional area which we notify by AB using, so AB horizon, say 5 centimeter deep transitional layer, and then below that from say 25 centimeter all the way down to 85 centimeter. This is the reddish layer in the soil, and this is essentially the in soil terminology identifying the soil order here. And this is blocky material. We refer to this before that it is enriched by iron and aluminum oxides, and it has these concretions in it, which is just an aggregation of iron and aluminum oxides. And if we have a color book, we can take a color measurement of it by moving a bit of soil underneath the tabs and then find the closest match. And I seem to find that on this page, which is a 7.5 YR yellow-red color combination, I seem to find a match which is for value is 6, and for chroma is 6 to 8, and this is what we record.
Speaking of color, I was noticing an interesting aspect at the bottom of the pit. Can you talk about that color differentiation at the bottom of the profile here?
Yes, Rachel. Below about 65 centimeters, we see a change in coloration in a B horizon. So this, of course, represents another layering in horizonation here. So the top uniform layer, I would call it BF, and then coming down here below say 65-70 centimeters down to the bottom of the pit to 90 centimeters, we see color differences.
What causes mottling?
We see different coloration in this deeper horizon, reddish color, and beside it somewhat lighter yellowish grayish color, and this is what we refer to in soil terminology as mottling. And this is caused by a periodic fluctuation of the water table. We refer to the seepage waters already, and heavy rainfalls during the winter build up a water table in here, and this creates the year seasonal fluctuation of the water table, and this causes this color difference, which soils people refer to as glaying. So in this case, I would call that horizon the BFG, G referring to glaying.
What about what's below the B horizon? Can we talk about the C horizon here?
Yes, the C horizon is a different type of parent material. This one is really indurated and compacted, and glacio-marine material deposited from the sea, and later on soil forming factors and actions, penetration of silica indurated this material. And because it's another type of parent material, in a horizonation we would have to give it another symbol, a Roman numeral 2, indicating that it's another material, so we would call it a Roman numeral 2 CG, because it's also waterlogged periodically. And the similar glaying action, which is acting on a horizon above it, obviously acting on this layer too, so I would indicate it by the G subscript.
Please summarize for us the sequence of horizons here.
So Rachel, the first organic horizon here is very thin because of the rapid decomposition of organic matter. This we could just refer to it as a litter layer, and this is only 2 centimeters thick. And then the mineral soil is starting at the 0 mark, and this the first layer, 5 centimeters thick, is well known by gardeners as a crumbly structured AH horizon, and this we would designate it as AH1. And then below that there is still plenty of organic matter incorporated into the soil here, from 15 centimeters to 20 centimeters. And this one, of course, is loaded with roots, because roots, of course, this is where the major biological activities are taking place in the soil, and that's where the roots are concentrating. And then below 20 centimeters we start to have a B layer of the soil, and this is characterized here by the incorporation of iron and aluminum oxides, which somewhat cement this soil. The iron aluminum oxides are the most resistant secondary soil forming minerals, and they accumulate in this layer. And the first portion from 20 to say 60 centimeters is since it's iron enriched, we would refer to it as a F, standing for the chemical symbol of iron, so it's a BF layer. And then below the BF layer we have color changes in the soil. Reddish and grayish colors alternate, which is the result of the periodic water table fluctuation, and this action is referred to as glaying. So we would designate that layer as BFG. And then, of course, below that layer we have the other parent material of this soil, the compacted glacial-marine deposit, which is cemented by silica, and that's why, and it's also under the influence of periodic water table fluctuation. So this would be designated as, because it's another parent material, Roman numeral 2C. A glaying action is indicated by G, and so the total name of this would be, a designation of this would be Roman numeral 2CG. And that's a soil profile here. Now, of course, we have to come up with the classification of this soil, which is in the Canadian system of soil classification, because of the iron and aluminum enrichment in the B horizon, would be the podzolic soil, and then it's characterized by the deep organic enrichment, and that would be the sumbric adjective. So this would be a sumbric ferrohumic podzol.